So let's have a look. So a doctor claims that the past records are out of date and the proportion of adults with the allergy is higher than the records indicate. So what it's saying here is that the doctor is so far posting out a claim. So we're going to be doing hypothesis testing here. And his claim is that there is a higher than an average allergy rate. Okay, so this is looking at a greater sign. We'll get to that. Now, a random sample of just 500 adults is taken from the population. So now our binomial is going to be 500 with, of course, the same rate, because the previous question states that this is for a large population. And this is based on past records. Now, according to this statement, of these 500, 5 are found to have the allergy. Now, one thing to note is that this 5 out of 500 business is not a proportion of a binomial. This is actually just found from this random sample. And remember, the binomial in this case, at least this type of question, is modeling this proportion from past records. So this is pretty much the rate given, the fixed rate given. Okay. Now, let's have a look. So this 5 is we're pretty much going to compare this 5 to the higher than average claim. Okay, so that's where the 5 will come in. Now, a test of the doctor's claim is to be carried out at the 5% level of significance. Now, let's see what that means. So state the hypothesis for this test and use suitable approximation. Okay, so first things first, we know we're going to use a binomial test. And in this case, we're going to use a Poisson approximation. Why? Is because we need to know that we have a very large sample size and a very small proportion. So multiplying out these together, we're pretty much going to get a lambda value and a variance which is more or less similar. So we can just say the rate is 2.5. So 500 times 1 over 200 gives us an average of 2.5, or lambda 2.5. And here's the reasons why. Now, hypothesis for this is just simply telling us that the probability that we know is 1 out of 200, and the claim in this case, according to the doctor, is 1 out of 200. Now, having a quick look at the tables. Let me see if I got the tables noted here. Ah, damn, I didn't paste it in. So having a quick look at the tables, we can firstly work at the probability that y is greater than or equal to 5, because we know that there are 5 found to have the allergy, and this doctor claims is higher than average, or higher than 5. So therefore, just using tables, we can do 1 minus 1 less or equal to 4, which is of course the reverse of that. And doing so, well, we can get this probability in the tables. So the point of this is to check whether or not we can reject the hypothesis at 5% level. If it's less than 5%, we can reject the null. In this case, we get about 10.88%, and that is definitely not less than 5. So we can say that there is not enough evidence to reject the null hypothesis, and therefore we that the claim is not significant. So in other words, if we don't reject the null in this case, so we're gonna pretty much keep this, and we're gonna assume that the proportion of allergies is actually more or less the same, because looking at head on 2.5 for this, and the previous one we had 3.5. It's kind of the same. I mean, it's not a big difference. Yeah, the huge number of adults is not a big difference. This is claiming that there is some sort of significant difference, but not really. So in other words, we say reject the claim, so therefore doctor's claim is not supported, and that's it. Okay, let's move on to C.